Albert Einstein's theory of general relativity completely changed the notion of the universe. It shed light on the birth of the universe, planetary orbits, and black holes. It also has very practical uses, like in GPS navigation. But what exactly is this theory, and why was it so revolutionary? Until the early 20th century, physics was mostly explained in terms of Isaac Newton's laws. For Newton, gravity was a force generated by the mass of an object, causing them to attract to each other, heavier objects pulling others more intensely. This is why we stand on the ground on Earth, said Newton. It attracts us to its centre, and it's why planets move around the sun. But imagine if the sun disappeared completely. According to Newton's theory, the planets of the solar system would instantly abandon their orbits, as there would be no gravity attracting them to the sun. For Newton, gravity is a force with immediate action, regardless of the distance between the bodies. But according to Einstein's calculations, light was the fastest thing in the universe. Nothing could travel faster than light, not even gravity. Light takes about 8 minutes to cover the nearly 150 million kilometres that separate the Sun from the Earth. So, if the Sun disappeared, how could the Earth go off its orbit before us Earthlings stopped seeing sunlight? Problems like that suggested to Einstein that gravity could have a different explanation than Newton thought. Between 1905 and 1915, Einstein developed the theory of general relativity. He imagined the 3 dimensions of space and the dimension of time together as a kind of fabric surrounding us, shaped by the presence of celestial bodies. He called it space-time. Imagine the sun as a heavy bowling ball placed in the middle of a trampoline. The ball makes the surface of the trampoline dip, right? This curvature is what we feel as gravity. So for Einstein, the Earth and the other planets remain in orbit not because the sun attracts them, but because the sun is such a massive star that other celestial bodies follow the curve it generates in the space-time fabric. Now, gravity is no longer considered a force of attraction between 2 bodies, as Newton thought. It is an effect of the space-time curvature on bodies. So according to Einstein, what would happen if the sun disappeared? His theory says this disturbance in space-time would form a gravitational wave that would travel to the planets at exactly the speed of light. That means we would see the sun go dark at the same time as the Earth changes its orbit. In other words, what Einstein demonstrated is that until then, we had been seeing the universe in the wrong way. The general relativity theory turned Einstein into a world celebrity. Because of him, science and our imagination could fly higher and higher. General relativity not only surprises scientists, it fascinates us all.